seem like anything. I guarantee you, I can go home, won't be there 3 minutes. And it sound like a damn 500 cicadas.
So you, what you're saying?
What I'm saying is, it's got to do something with it.
The only thing I can tell you, Mr. DeWaller, is I've got a meter on my house with my children. I've had it there for years.
Yeah.
I have no problems with it. And I know these meters inside and out. I work with them every day.
Yeah.
I know, in studying the RF characteristics of these cell phones are tremendously worse than that smart meter.
Oh, that's right.
So you're saying the cell phone was much more powerful, the signal off of it, than the signal that comes off of this?
Well, no, remember, the transmit power, your phone transmits at 0.6 of a watt.
0.6.
The meter has a 1 watt transmitter. So the meter transmit at a higher power. However, you got to remember
Oh, thanks, sir.
the
Okay, so this one here, is that what?
No, sir. That
What does all this mean? Because
this is an ANSI, which is an international standards agency.
Right.
They create guidelines that we and every other utility in the world have to abide by for testing the meter. ANSI created a guideline for creating meter labels. You see the FM, that stands for Form 2S. That's just the type of meter. If you were to pull this meter out, it'd have 4 stabs out the back of it. There are some that have 6. There are some that have 13.
So this has 2, you say?
This has 4.
4.
You have.
Oh, where it connects to the juice in and to the juice to the house.
That's right.
Okay.
That's right. That's what the Form 2S means.
Yeah, see, Georgia Power has been out here numerous times, and they checked it one time. Now, I was going to ask you, is this the same meter that when they put this meter in that's always been here, or has Georgia Power ever changed this out?
Your meter was installed, I believe it was April 2009.
And that was manufactured in October of 2008.
That's what that 1008 means?
Yes, that's right. The bottom here, that's right.
Yeah. What does what I guess KH means?
KH means that, you know how the old disc type meters, they were
fast. What does it stand for?
KH?
Yeah.
I don't even know.
It's equivalent. It tells you how many the pulses that is how which is how it records.
That's reading it.
You see this line
It's
moving?
equivalent to the old disc current.
You see the line moving across the bottom here, Mr. West?
Right.
That's the digital equivalent to the old disc. So the faster that line is moving across the bottom of your display.
But that's what that KH has to do with.
The KH, every one time that you see that dash move across the screen, that's 1 kilowatt hour.
Okay. What does the 60 HZ mean?
60 hertz.
Which is, fill me in.
Well,
what is a hertz?
It's hard to
I know when you like doing sound recording, it'll have
same idea.
the same idea.
Yes, sir. 60 hertz is what all of the power systems in North America run on, and 6 hertz just you have
Is that like a cycle?
Yes, it's like a sine wave.
This repeating every 60 hertz.
Which is, well, 60 hertz is that like a distance or
no?
Volume, amplitude or something?
No, sir. It's say you've got if you have a graph.
Yeah.
It AC is oscillating, so you have a sine wave. It crosses 0 60 times a second. A hertz is 1 crossing per second.
Okay. Okay. All right. What is the now you say Sensus made these for Southern Company?
Yes, sir.
And where were they made at? Do you know?
You mean where they're actually manufactured?
Right.
I believe they were manufactured in Mexico.
Mexico.
Yes, sir.
Okay.
Sensus is based in Raleigh, North Carolina.
And is that their brand? The Icon?
Yes, that's called an Icon Generation 2 meter is what that's called.
Okay. Now, you said that it transmits only a few times a day. Now, when it transmits, does it just transmit what it's reading then? Or does it collect the information and then, like, upload it? You know what I'm saying?
It does. The meter sits there, and every hour, it looks at its internal storage, and every hour it looks at the display and says, what's my reading? And it stores that in memory.
And what kind of memory is that? Is that like...
it's just an electronic...
Is that on a chip, or is it...
Yes. And so it saves that reading in its memory, and then every 4 to 6 hours, depending on signal strength, from the tower. So if it's got a great, if it can see the tower real well and communicate with the tower, it'll communicate less often. If it's in a bad area where it's having trouble talking to the tower, it will try to talk more up to 4 times.
So that though, what you're saying though, when it's trying to communicate, that's built in it. It'll do that automatically. Like if it can't get to the client, it'll keep expanding its reach or power or something to get there.
No, it won't change its power. It simply tries more often.
Oh, I see.
Yeah,
see, and then the tower answers. The tower lets this meter know that they've received what this meter has.
Does it really?
Yeah.
Well, there is no verification from the tower. When it transmits, it just transmits. Well, I guess there is a verification because if it can't talk...
I was going to say it'd never shut up.
Yeah. Right.
It'd keep hollering until you say, I hear you.
The tower acknowledges receipt
cool.
of data.
So when it records on the chip, the power, is that like a raw consumption of what's going into the house, or is that like a detailed type of characteristic thing? Like, okay, it knows this is operating. It's I don't know how that works.
It doesn't show you a difference in frequency. It just takes what that number is right there on the screen and records it. It doesn't. Have the resolution.
So you can't tell if I'm running a Marshall in there or I'm running a dishwasher?
No, sir.
Okay.
That's another one.
Well, I was like, yeah, I know. I was like, okay, well, I know it knows it automatically when power's, being used, but I'm like, well, does it know the characteristics of what you're doing?
It will report if there's an outage. It will tell us if you have an outage. It'll report to us that there's an outage, which obviously allows us to respond faster, more efficiently.
Yeah. So if it's... So Georgia Power knows every time it hits the tower, you get that information and then you guys have it, right?
Yes.
So every time this thing talks.
Yes.
That you receive.
That we receive.
Right.
At our software systems in Atlanta.
Okay. So if it's talking and you're not receiving it, you don't really know if it's talking or not, right?
Well, we know that the transmitter is only programmed to talk 4 to 6 times a day, and that's what we just proved.
Okay, now is that built in? Is it automatically set on the, like in the instruction? I don't know. Does it have an instruction chip like a computer does?
Yes, this is a mini computer basically.
Okay, so it's programmed basically. Okay, it's time, talk. It does it like that.
Yes.
Okay.
In simplified terms.
And Georgia Power knows when those times are.
No.
You have no idea of knowing when this computer's supposed to start hollering.
No, there's an algorithm built into.
Right. I'm saying, is it time based or is it? What is it? How does it make that decision?
There's an auto tuning process. So when you install this meter the first time, it cranks up and transmits to the tower. Depending on how well it can talk to the tower, it says, okay, well, I'm going to talk 4 times a day. I'm going to talk 6 times a day.
But it only ever talk 4 times a day, as long as it's going to the tower properly.
Yes.
Okay. Now, you say it's interfaced with the storage medium, the information that you get. I'm saying the meter records the power, I guess. I mean, I don't know how it actually records the power, but that's converted into information that's stored on a chip, right?
Yes.
Yeah. Okay. So
a meter looks at two quantities,
voltage
and current, and from that, and then of course uses time to calculate your kilowatt hours used.
Right.
Kilowatts are power, and you can multiply voltage times current to get your power.
And basically, I mean, you say it's recorded on a chip. Well, what kind of interface is used? I mean, how does it record? Because if you put a meter to something, you see the thing, you see your signal strength. How does it record the interface between, say, the raw power and the computer in the actual unit there? Has it got some kind? How does it read the current? What I'm saying, how does the computer read it? Does it go strictly by what is recorded through the raw juice, or is there some kind of like you don't have a
meter in your car, do you?
like a solid state, like a board in there that interfaces.
There is a circuit board. There are actually two circuit boards.
Okay.
The bottom circuit board is a power board. It's where the current flows. It uses something called a Rogowski coil.
Okay.
To measure the current.
Okay.
And then the voltage, of course, comes straight off the bus. This is a 2S meter plugged into a 240 volt service. You see there it says 240 V. 240 volts. So it's measuring the current, it's measuring the voltage, and from that, the little computer inside the circuit board in the meter is measuring those values and using them to calculate the kilowatt hour.
Now, what would happen if you said, what did you call that board that you said was measuring the
current?
Rogowski coil?
Yeah. What would happen if that malfunctioned? I mean, the meter would still work, right?
The meter may continue to stay powered up, but we wouldn't show any kilowatt hours. It would change. Right now it says 18226. It would stay that forever.
But what I'm saying though is if the interface was to be messed up where it's recording, it would still work properly as far as like it communicating. Yeah.
Yes, and what would happen is if something happened to the measurement circuit and it quit measuring, then it's going to continue to transmit that wrong value to Georgia Power, and the Georgia Power system has thresholds. It would look and say, hey, for the last year, Mr. West's meter has been incrementing on average of whatever.
But they wouldn't let it go a year.
No.
There would be a red flag at the other end.
That's exactly right.
And they would go, something ain't right.
And they would dispatch a work order to send a meterman out here to come and check your meter.
Now, when you say you got a problem and you just said you send a man out, say I have a problem, which I've called Georgia Power, and they've come out here. Now, the problem I described to them, I told him exactly what it was doing. Well, the second time the guy got his meter out and he checked the connections, okay? First time they just come out and, they looked at the connections and all that kind of stuff. I told him, I said it was similar to like a transformer, what you hear in a substation, or if you're working on like, say, an amplifier and you've got the cover off. And I said, I just was worried, could that be a bad connection somewhere? And so anyway, they checked that kind of stuff. Because I said, it's very annoying. I said, it's not slight. And so anyway, they looked at that. Well, the second time he checked the meter, whatever, I guess he just checked the connections. He didn't do none of this. He just, opened and stuck his meter up there. And so anyway, then some engineers come out. There was two of them. And I told him, I was like, well, I don't know if it's your transformer. I don't know if it's somehow connected, where it comes in and those splices are up there. I said, I don't know what it is. It's like, well, I told him again, standing in a substation or near a big radio unit.
Static.
Well, no, not static. If you stand next to a big radio unit, when it's on, it's juiced up. I mean, you can tell.
Right.
You notice.
Right.
So anyway, the two engineers didn't check the damn meter, man. So anyway, I called him again. He called, one of them gave his number, said, well, call me at night. And I was like, will you bring some equipment out? Yeah, well, he never did. I called him a couple times. So anyway, after a while, that's where I had to file the complaint. I was like, well, what would be doing this? I knew it was power related for things we're not going to discuss here. But I said, well, why would something be doing that, what I noticed? And, not only why, where's it coming from and everything. I didn't know anything about these things. And Georgia Power never come out here and really said anything to me. And so anyway, I was like, well, what would be broadcasting a radio signal? Let's put the tinfoil hat on, all that good shit. So I was like, well, what do I have? Do I got a radio? No. Do I have any kind of radio equipment? Well, no, not really. I mean, I don't even use a wireless guitar. I got a wireless phone in there. So anyway, you disconnect all that stuff. And then you say, well, the only radio that's left would be this one. When you know that it's here, which I didn't know it was there. When I found out it was here, I started looking at the information, and, you get a bunch of crap information. That's why you're out here. Because, I wanted to know the real deal on it. And it's like, well, radio is a tricky beast, so to speak. And that's why, I'm asking these questions, because, well, there was a problem, and I already had Georgia Power out here over a period of almost 2 years. So then when I found out it was something that might possibly, like I say, you showed me this stuff, and I'm like, well, that's, that doesn't look like anything, but, that's why I'm asking these questions. I don't know. It's just really funny that Georgia Power would never approach and do this. Check it, not even have a handheld unit. You know what I'm saying? Just to look at it and say, well, maybe it's turned on. You know what I mean? Maybe it's turned on all the time. Because like you say, it can turn on and off. Well, they never did that. So, you know, we're here doing this, and that's why I'm asking these questions, because I'm like, well, that's just odd.
Let me apologize on behalf of Georgia Power for us not being more responsive to you, Mr. West. I can tell you that the engineers that came out before were distribution engineers, and their job is designing power lines.
I can tell.
They're not meter guys. And the meter man who came out here, his job, he knows the meter and how to check for connections.
Well, yeah, like you guys got what? Degrees in radio stuff, or?
No, we're all electrical engineering degrees.
Well, I mean, you know, it covers that to a degree.
Yes.
Yeah. I mean, you're not like a physicist.
No.
But this is pretty good physics this thing's got. That's why, you know, I always like, well, I can understand why a meter man really wouldn't pay attention to it. And that's why I ask you, is this the same unit? Because after I made the complaint, well, there were changes in the problem. And I'm like, well, did Georgia Power come in and change it? Because I don't know if you did or not. That's why I ask you. But over a period of 2 years, when you make complaints and then finally you make a complaint to the Public Service Commission and the problem seems to change in character, that kind of tells you, well, there was some kind of problem involving that. You know what I'm saying?
Yeah, you're referring to coincidences, and I can only tell you, I didn't even know you'd made a complaint to the PSA. That was not, Ben and I had no idea of that. We just got a call.
Georgia Power don't tell y'all that?
They did not tell us that.
Oh, good Lord. Well, see, like I'm saying, I wouldn't have ever, it just went on for a long time. And it's very irritating, and it's radio that does it. You understand what I'm saying? Mm-hmm. I mean, like I say, I don't really understand all this stuff because I'm not schooled in it, but I've been a sound engineer since I was 12 years old. So I've always been around equipment. Mm-hmm. And I'm like, I know exactly what a radio does. You know, I've been around some nice radio gear. And this is some nice radio gear. And that's why I'm like, well, you know, if this thing was to be malfunctioning, you can have a serious problem.
I got a question to ask you.
Yes, sir.
If his meter goes off right now, how does that know which meter's off?
Sorry.
If that meter went off right now, how would y'all know, or not you, but the tower know that that meter's off?
Well, the tower is sitting there continuously listening for any meter that will talk to it. And so when this thing transmits, it takes 1/10 of a second for it to transmit its reading and this meter serial number, and you see that, actually it's this number, the FlexNet number.
Right.
That's how it identifies this meter. And so it takes those few pieces of information, routes that back to computer systems, the server farms in Atlanta, and matches it up with the billing system. Oh, this belongs to Mr. West.
All right, I'm going to tell you what happened. I went on a 4-day seminar. I left in, when I leave September? I left in September. I was gone 4 days. I turned everything off in my house. I turned my computers off at night. I got a switch that I hit and kills everything. I used to have UVerse. I found out what it'll do to you, so I don't have it anymore. So
UVerse? It's dangerous?
UVerse, yeah, it's dangerous. I don't turn my cell phone on at night. My wife doesn't turn hers on. We use these for emergency. As I said, it sounds like cicadas. It's right here.
What is a cicada? How does that sound?
Cicadas.
Is that them bugs that get in the trees?
Yeah. Cicadas, yeah.
Well,
but let me tell you, while I was gone those 4 days, my power went off twice. And I went next door to my neighbors because they know when we go. But like I said, I got 2 show cars. And I'm not bragging, but I got some money. I inherited it. I'll just be up front. So they watch out for that. So I asked them, I said, did y'all have a power outage? No. Power didn't go out? No. I said, are you sure? Yeah. Come in here, I'll show you my digital clock. We have digital clocks. The old style, now not the new style. Theirs is off. Mine's sitting there blinking. My microwave's sitting there blinking.
So
somebody cut that power somewhere. But where? I'm the only one now. And I told this to Georgia Power when you gentlemen wasn't there, down at the PSC meeting. I go down there and I give them all the information that I can get. It goes in one ear and back out the other. It's not y'all's fault, I understand.
No, this ain't none of y'all. I mean, I'm not blaming you guys.
Big corporations, both of us did. I don't know about him, we did. We know how big corporations are.
We have family.
The complaint I've got about it is, how did that thing know to turn off and how did it know to turn back on? There's one thing I thought about. I wasn't using any electricity. There was nothing on but my refrigerator and my freezer.
So,
That's
but
it now.
I'm gonna ask him because this
in this meter.
Yeah, I know that.
it can't know that. Can it actually know that if nothing's on in the house?
No, it knows that the power's out.
I'm saying no. If say there's nothing on.
This meter's doing nothing but looking at two variables, voltage and current. That's all it's doing.
So if you're not drawing any current, it's not recording anything.
It's sitting there looking at voltage. It takes voltage and current to accumulate.
So something's got to be on before it kicks in and starts
Absolutely.
monitoring.
See, that's the reason I was asking. I don't know when it got off.
Now,
I knew it cut off, but I know it was cut off.
we don't know where the tower is that this unit communicates to.
No, sir.
And we know we've talked about the signal and all that kind of stuff. Now, when it's trying to communicate, because you say the tower is always listening for it.
Yes.
If the tower is not getting that, how does it? Okay, if it's not getting a signal, this is the unit that's telling the tower that the tower has to tell this unit to quit sending, right? This will continue to send the signal until the tower responds to it, right?
No, it will try up to 6 times a day, and if we can't talk to it,
Yeah.
there's 2 reports created. One's called a 12-hour stale, and then one's called a 36-hour stale.
So it's like in 12 hours, you know there's a problem.
There's a list of meters that we haven't heard from in 12 hours.
Yeah.
Okay, we're going to wait 36 hours and check again. In 36 hours, a report. Hopefully, that report's smaller, and those meters creates an order.
Now, say you send a man out, and he comes out, and they're saying, well, we're not getting it. Like with some software or unit like that, or Census, I guess, would make it. Census is how you interface with this thing, right? I mean,
Census is the company that makes the system we
to
use.
turn the power up and down, you have to use stuff they made, or does Georgia Power have a way to do that? To turn the signal up, so you can receive it.
You can't boost the signal at all.
No, this is a 1-watt radio, and that's all it'll do is 1 watt.
So otherwise, the signal can't be boosted; it can just be on. That's what you're saying. It's going to put out. There's no way it'll ever put out anything more than that.
No, it can't. It's just a 1-watt radio.
Okay, so Georgia Power, when you send somebody out here, they can turn it on
One of the
remotely.
When he comes out, he'll have that same
program. And what they'll do is they'll actually look and say, okay, hang on, this signal strength right here, this isn't getting good signal strength, it's not communicating with the tower. Well, they come out here and say, okay, this meter is working properly, but it's not getting to the tower. So they'll identify that as a problem. There's nothing they can adjust inside the meter.
So if it's not getting to the tower, how do they fix that?
They'll add a repeater, or
Where's that at?
I don't think you have one here. I haven't heard of anything being in this area.
No, sir. It would. Sometimes what they will do is have. It wouldn't increase the power. It would just be an external antenna occasionally, and we generally don't have that problem at all. I can think of a handful. But with the external antenna, all it does is it broadcasts a little bit higher. It doesn't change the power.
You're talking about higher, like terrain-wise, like
Correct.
up there.
Correct. They put something on a,
See, they put it on that pole over there.
and it doesn't transmit anything. All it does is it's just like, and it doesn't increase any of the power. It's the same signal that's coming out of there. It's just a clearer path.
And so that's, what do you call that when you set the antenna? Is that like, do you move it directionally, or how does the antenna, like, used to with the old style antenna, you'd go around doing this?
Yagi, directional antennas.
Yeah, now this thing right here, is it at a certain angle, the antenna, and then you adjust that?
The antenna in the meter right now?
Does it have a antenna?
It does. The antenna is what they call a strap antenna.
Uh-huh.
It's inside the meter, and it's actually designed to propagate really almost 150, 160 degree angle this way. So the antenna really is not designed to transmit behind it. It actually, the RF waves will...
you mean it does transmit directionally? I mean, it does. It knows how to point.
Well, it's not pointing, it's just transmitting, and the antenna design has because it knows then,
Think of a shotgun blast.
Exactly.
Exactly. That is going.
Now say your cell tower's over there, or over here.
Right.
Now, and it's going out this way. How is it going to get over there?
Well, it ain't like shooting a shotgun in that sense of the word, because RF bends. I mean, it's just like your radio in your truck. Yeah, you go around the corner, you can still talk to the. You pull up in your garage and close the garage door.
So you're saying if you guys were in front of the house right now, you could detect this thing?
It's possible, but it'd be very low.
Very low. But if the cell tower's far off, how in the world is?
It's the sensitivity on the tower.
Let me talk about like you're familiar with bandpass amplifiers. How it kind of crunches in, it takes some of the signal, trims it off. This is a bandpass filter. So everything else besides this narrow band,
right,
it doesn't listen to all that.
Right.
And so it's just listening for that little band, and it's only listening for these. So it doesn't have to be very powerful.
Now, what frequency is that at?
It's listening for these frequencies that's coming out.
And the frequency was, what did you say it was?
941.
941, which is I don't know, that's like a handset unit or something like that. Don't they transmit it about that?
You mean like a little walkie-talkie radio?
Or something like that, or
walkie-talkie's around 400, like a
cordless
phone,
yeah,
like your house phone.
Right.
If you have that, that's in 900, but that's on unlicensed. This is on a licensed frequency.
But it's the same frequencies, right? Similar, so close.
Very close.
Okay. All right. Now, so you say if you have a problem with this, it's basically from the tower here that you correct it because you really can't do much with this, right?
We can't do anything with the transmitter.
Okay. So can that tower, is it's networked like I don't know, Wi-Fi too, or is it connected to hotline? I mean, hardline.
They're connected hardline. Some of them have a cell phone connection. There's different ways.
Some of them fiber optic.
Some of them fiber
now,
optic.
what other gateways beside these meters are on those networks? I mean, I know Georgia Power has a gateway to get on them, but how, like say Census, their equipment there, obviously it can get on it.
Census, the company, cannot get into the Southern Company network. No.
No. I mean, but it can get on the meter.
No.
Well, what was that?
That's Southern Company equipment.
This is our frequency. They don't.
But that's Census equipment, though, right?
Yeah, we're using the Census system, absolutely.
But I mean, that's like saying, well, you know, I build a boat, but everybody else uses it, but I never have. You understand what I'm saying?
No.
Well, no, Census can't build equipment and just give it to you without knowing that it works.
Yeah, well, they're blocks. I'll take up for Georgia Power.
Yeah.
This is in Congress with that.
Right.
But I can't get on that.
Census can't use their own equipment to get on their own equipment.
Exactly.
Really?
Really.
That's amazing, man.
That's called a patent.
Huh?
That's called a patent.
Well, I can understand for security reasons why they wouldn't be able to do that, but you're saying that so nobody else can ever access the information broadcast on this except for Georgia Power.
Well,
no way, no how.
Let's say, for example, Miss West, we had a meterman that quit under unfavorable circumstances. And let's say that he had some of our equipment and he came here and...
okay, that's what I'm saying. So whatever the scenario is for somebody having equipment, there is ways to use equipment to get on it.
What I want to share with you is there are processes inside Georgia Power and Southern Company to keep that kind of thing from happening.
Once he's terminated, he's terminated. It's like a Brinks armored car driver. He has keys to a certain amount of Brinks.
I understand that. So,
but he can't go to the next truck in the yard and get in there and get the money.
That's exactly right.
Right. Okay. I understand that. But it is possible, though, for somebody with the right equipment, right?
If someone here besides us had that equipment right there and they knew the passwords, they could probably get in.
Or bad meter man, or somebody in the company that wasn't right. You know what I'm saying? Yeah. Okay.
But here's the challenge to that.
But red flags would go off.
Right.
But here's the other challenge is I don't know what they would get. I don't know.
Oh, no. I'm not saying they're going to get anything. What I'm saying is they can just access the network that this uses to communicate.
The only thing they could do is talk to your meter. They couldn't get on the actual network. Even our equipment we have here.
That's what I'm saying, though.
With this little transmitter.
They can know, like say, just what you guys are doing, testing it. Say,
yes.
That's basically all they could do is run test, turn it on and off, and that kind of stuff.
If Georgia Power had a consultant here rather than actual employees, when we gave them our equipment, our passwords, they could set.
Okay, all right, cool.
All the numbers. I mean, it's you can't really get any information from it, as you can see. I mean,
there's too many numbers in there.
Oh yeah, I mean, we've already, we know that there's really no information that these things transmit. I really can't understand. I mean, I can understand why you would put something like this, but just the information and the use that Georgia Power is getting out of this, it doesn't add up. You know what I'm saying? I mean, you've got a thing here that's causing problems, which I'm not even going to talk about anybody else's problems. I'm just going to talk about the ones we got here. And I know since you've got millions of these things, I asked you, when I talked to him, I said, you had any complaints about these things? And he said, no.
It depends. I mean, when the videos came out on the internet.
No, I ain't talking about no videos on the internet. I'm talking about me talking on the telephone. I asked him, I said, man, this was May, I forget the date. I said, you had any complaints about these things? No.
In what regard? You mean high bill complaints or?
Complaints about these meters. That's what I was asking. I said, my exact words were, have you had any complaints about these meters? And he said, no, none at all.
Are you talking about billing complaints?
I'm just talking about any kind of complaints. Because we didn't know really what we were talking about. I mean, I knew there was a radio in the thing and all that kind of stuff, but I'm like...
We've had people concerned, just like you have been, about the RF concerns or RF effects from a smart meter.
After they've had...
because of the internet videos that have come out.
But I mean, I'm talking about, though, I didn't ever see an internet video on this thing for a long time. You understand what I'm saying?
Mm-hmm. And we didn't have any complaints for the longest time.
But I was complaining before I seen the video. Do you understand what I'm saying?
Yes, or now
yes.
I do.
Yes.
So the history that you shared.
Yes, I was complaining long before I knew there was any. And then, you know, when I seen it, I was like, well, they'll just come take it off or replace the unit or something. Mm-hmm. But then, you know, you run into all this, whatever it is, and I'm like, well, that's a bunch of horseshit. So that's why we're out here. And I'm like, well, there was a problem there. And it's a problem, I guess, if I could redo the experiment, I could make it do it. You know, understand what I'm saying? So you've already described that, yes, it can make that kind of problem. See, what you're talking about, whenever you transmit anything, and it uses a radio signal, you can have all kind of propagation issues. I don't know whether the tin roof did it, the tin building, other meters talking to one another, talking to the tower, but there was a problem that it caused.
Well, the only thing, my comment to that, Mr. West, is you're exactly right. An RF device can cause propagation issues if
yes.
there's enough power and energy. But what I'm trying to point out is that a meter doesn't have enough power to create it's no different than your cordless phone, your cell phone, your microwave.
Oh yeah, I understand it's no different, and I understand those devices are far more, you know, they're more dangerous. Really, they are.
Because we wear them on our sides.
Oh yeah, well, you know, I don't talk with a cell phone all the time. You know what I mean?
My microwave. I used to stand in front of the glass waiting for my soup to cook or whatever.
Is that not smart?
Well, there's no problem with it. Technically, but since I started taking measurements and saw that it was much higher than a smart meter, I just take a couple steps back and watch it.
Yeah, I hear you. So this thing, if it's small, the power is small coming out of it. Even if it was to say be dangerous somehow, it would be a long time before it would actually be dangerous. I mean, it's so low a power that all you're going to get basically is, I don't know what you would call them, because like I say, I don't have a degree in it, the spatial effects. Do you understand what I'm saying?
Yeah, you're talking about ionizing effects versus non-ionizing?
No, I'm talking about like if me and you were to go get a nice radio set and bring her out here and turn her up, and I'll say, well, can you tell it's on? And you'll be like, yeah. You understand what I'm saying? When you got something on, juiced up, well, you know, you don't really listen. See, your body reacts to that because, you know, you're electromagnetic. Your body reacts to something that's powered up. If it's at a certain strength, a certain frequency, your body reacts to it. I mean, you can tell. You know, that's how come sometimes when you go to a substation, you hear it. Not that it's connected, but you got a lot of power in it. It's juiced up.
Yeah, you hear what's called 60 hertz hum from a
60 hertz?
Which like, is what we talked about earlier.
Well, what does that sound like?
I know it, but I mean, I'm going with the federal law.
The hum.
Yes, it's just a hum.
It's a constant.
Does it modulate? I mean, or does it just go continuously?
Constant.
Yes, this is a constant hum as long as that equipment is energized.
So, if it's like, say, turning on and off, though, it's going to be a variation in that sound, right?
Correct.
Okay. All right.
That's a lot of energy.
I know that, but you can. But even
See, this is constant.
yeah,
That's continuously coming in there. That's constant. Now it varies when you go inside and turn it on and off. That's
Right.
what makes it fluctuate.
okay, yeah, I understand that. What I'm saying though is,
It's a radio frequency.
when things power up and down, there's noticeable. Besides your readings, I mean, you can be standing near something and notice it when it powers up and down.
I can tell. I mean, if you put my refrigerator on, I can tell when you got it on.
Any and the only way, because like I'm saying, you're not actually hearing it.
Power line here.
But the only thing you would notice would be the radio broadcasting, turning on and off. I mean, you're not going to notice anything else that it has to do with it.
Yes, sir.
I can't tell when the meter transmits.
I was gonna say,
Even if you're like in here and it's on, there's no way that you're ever going to be able to notice it.
no, first of all, it's instantaneous
It's a tenth of a second.
and it doesn't last. It's on and off.
Okay.
And I doubt very seriously if you would ever notice that, even if you're standing right here with your ear to it.
Well, no, you're not. That's not how you're going to notice it anyway. So, but what I'm saying though is, if it's communicating to the tower and it only does it for a certain period of time. If there is a problem and you have to make adjustments, like you're saying, whatever repeater, whatever it is, to actually get the signal, then you very well could be dealing with something that is on, not just for a split second, but on for extended periods of time, right?
Yes, sir.
I mean, there's no way around that.
I don't understand. I think we've already showed the meter.
Right. What I'm saying is when it's on,
Yes, sir. I'll get one.
what I'm saying is when the thing's on, it only, like you say, broadcasts a few seconds, a few times a day. But like you guys have shown, it can be turned on besides those duty cycles, like a demonstration, like you did for me.
If we're standing here, yes.
Right. So, how far would that thing work?
If I went to that tree over there, there's
It
a good
won't work.
chance it isn't going to work.
It wouldn't work.
Probably in between here and there.
Yeah. And you guys say this isn't like, what did you call them, a mesh system?
It's not like a mesh.
Yeah. So this one can never talk to that one or any of the others.
No.
Okay. So it's strictly going to your tower.
This one's
Peer-to-peer.
going to the tower, and that one's going to the tower.
Right.
But
Okay.
they're not pinging each other.
No.
Okay. All right. All righty. And you're saying this unit has software built in it?
As we call firmware.
Firmware.
Every electronic device that we own today.
That's like on the chip, so to speak, right?
Exactly. It's basically the software running on the chip that tells it how to act,
to do.
and smell, taste like, that type of thing.
Okay. So you're saying when it communicates, that's built in it too. Can you guys change that time?
The communication.
Yeah. Well, I don't know what you call it. What do you call that? When it-
The transmit time.
like say,
the
instead
time
of 3 o'clock
transmit,
today, we're going to change it and we're going to try it at 2.
It runs on an algorithm. It's kind of random. It's not.
We don't want all of our meters across the state communicating at the same time.
But you can't adjust that, right? Well, it's built in it.
We can go in and talk to it whenever we want to. The guys in Atlanta right now can, let's say for example, if your meter hadn't reported for 3 days,
Right.
before they would send a meterman out here, they would try to do what's called a ping. They would try to ping your meter and get a response back to see if
Right, using remote equipment like you guys have got out here, right?
Yeah, but they would use the software system downtown Atlanta.
Oh, okay. So that would come, what, through the tower?
That would come through the tower.
Okay.
It's as if I have trouble with my computer, I can call a number and then turn my computer on and let them in my computer, and they can repair that from
Remotely.
Remote access.
at the beach.
I hear you.
The guys at the beach sitting there, oh, I gotta stop.
Guys, I appreciate your demonstration here. It answered a lot of questions for me.
Okay, Mr.